So what we want to do in this section is kind of switch between graphing and derivatives and see how the two connect with each other. So what we have right here is a graph of a function. And what we want to do is describe what's happening with the derivative for each of these x values on the table. And what we'll do, and actually I'm going to change this where it says f of x, let's change that to f prime of x. So the idea being, if we're at -4, so we're right here, and the derivative would be the slope of the tangent line. So what I'm going to do is just roughly graph the tangent line here, something like this. So let's call that a +2. So what I'm doing here is looking at the slope. So I'm going up to right 1, and that's telling me a slope of just about 2. We're going to just estimate these as best we can. And let's go to -3. This should be a fairly nice one. Let's go ahead and say that's the maximum, and we have a slope of 1 right there. Or sorry, 0. Slope of 0 for our flat horizontal line. Let's see it, -2 here. Looks like that slope is about a -1. At -1, this one's going to be a bit tricky because we're at a corner here. When we have a sharp corner, it's hard to take the derivative because like just over here, it's more like our slope's going like this, and just to the right of it, it's a flat line. And it's kind of hard to tell what's actually happening at +1 with a corner. So what we can do is say that the derivative is undefined. It's going to be this switch between something negative and then this flat horizontal at 0. So we're going to have this jump here. So what I'm going to do is call that undefined and think of it as a jump between two slopes of tangent lines. We're going from something negative to a slope of 0. And even if it's not a clear jump, it looks a lot like a jump from something negative to something 0. But what we could have also done is seen it as creating another corner of just coming right up to something negative and then directly to 0. But let's go ahead and call that a jump. So then let's go to 0. And here we definitely have just a flat line. If I graph the tangent line, that's going to have a slope of 0. Same thing at +1. And at +2, we're going to have that same kind of jump. So because it's a corner, we're going to call that undefined for our derivative. And at +3, let's see, we're right here. Let's go ahead and try to graph that tangent line. Let's call that a +2. So again, slope, thinking up to right 1. And then at +4, it's going to be a little bit more steep. Let's see if we can get a good estimate for this. Let's see, something like that. Let's go ahead and call that a +3. Maybe it's kind of a 4-ish. Yeah, let's call it 4. Again, just estimating as best we can without our actual function to take the derivative and evaluate. We're just trying to get a little visual going. Okay, so from there, we want to make a sketch of our derivative function on the same axis. So now we have these coordinates. So like at -4, we're at +2. At -3, we're at 0. Then we're at -1. And then I'm going to pause at -1 for a moment. I'll skip that because we'll come back to that as a jump as we start kind of connecting our graph. And let's see here. At 0, we're at 0. 1, 0. 2, we're undefined 2. I'll come back to that one. 3 is at a +2. And then 4 is at a +4. Okay, so what I'm seeing is a decrease here. And then what we'll have is right at -1, like I was saying, is we still have these negative slopes here. They are getting flatter, so it is somewhat approaching 0, but it doesn't quite reach 0 because it doesn't completely flatten. Like here, we really see this curvature where it ends up being very close to flat. This one is still pretty negative. So what I'm going to do here is show that it's not quite as steep as -1, but it doesn't quite reach 0. And then we're going to jump up to 0. We're not quite equal there, but this is just to show that when we're just to the right of -1, we definitely have a slope of a tangent line that's 0. So we have a little jump there between the two, and at -1, we're going to be undefined for our derivative. And then we're going to have this flat line, and then at +2, we have the same thing. So like right here, it's still a fairly positive slope just to the right, but not quite a 0. And then just to the right is in fact a 0. So what we're going to do is go right up to +2, still graphing 0, but let's use an open circle to show we're getting infinitely close. And then let's go ahead and just be a little bit positive here for our jump, and then connect these. Maybe something like that. Okay, just a rough sketch of our derivative function. Now, when we have the actual function to work with, this is a bit easier because we would be able to use our derivative rules to take the derivative function, and then we could just plug in values to evaluate. Okay, what does a positive y value on the graph of y equals f prime of x mean for the graph of y equals f of x? So we're looking at here and here in terms of our intervals where we have positive derivative values. And what we're seeing for our function itself is that those are increments where we are increasing. Same thing here, increasing. So we have kind of, I guess, 3 trends of our original graph. We have spots where we're increasing, we have a spot where we're decreasing, and then we have this spot right here where we're just flat, which means it's constant. So we have these 3 pieces, and when our derivative is positive, those are spots where f of x, our original function, is increasing. Whereas where our derivative function's negative, which would be right here, that's going to match up with where our function is decreasing. So that was where f of x is decreasing. And then where we're seeing 0 come through, there's 2 scenarios that occurred. So let me just clean this up a little bit so we could see the zeros clearly. So we have a 0 right here, and then we have a whole bunch of zeros at this flat line right here. So the first 0 that we have, that's coming from a peak. So that's coming from a local maximum. So zeros will occur at our relative extrema. What we also see is it's occurring where we have a constant being graphed. So where our function itself is a horizontal line, that's creating a bunch of zeros as well. So 2 scenarios here. It's either a local minimum or maximum, or f of x was constant. So 2 scenarios for getting zeros to come through. Okay, that was just a brief little overview of kind of relating our original function and getting to this idea of graphing the 2 on top of each other and seeing how they relate. And what it's going to come down to is positives versus negatives and zeros, and how that relates to a rate of change on our original graph in terms of increasing, decreasing, or constant.